Okay, in this video lesson, what we're going to do is take a look at how we can go about drawing on our window. I mean, we've looked at how we can place controls on there.
Right.
There's going to come a point when you're working towards game design or even actually doing
Visual effects
type stuff where you're going to need to be able to do more than just put a control on the window. Where you're going to need to actually be able to draw on the window, like let's say some sort of shape or line or whatever, or, and even more important, start manipulating bitmap images, files that were created whether as resources or through Photoshop or whatever, and manipulate these bitmaps and display them as well on the window.
Exactly.
So in this lesson here, we're going to be focusing on that. You'll notice that the application that we've got open right now in .NET is back to the Hello World very basic window, the thing that we did in lesson number 2. There it is. The only thing that's been changed here is just our title bar. Instead of saying Hello World, it now says Painting.
Exactly.
All the controls and all that other good stuff has now been eliminated so that we're just back to something very simple to work with.
Right.
And Joel, let's go ahead and take it from here.
Okay. What I'm going to do is basically I would like to have some sort of window as our canvas. And in this case, we're going to create a control, the wxWindow control, that's going to act as our canvas.
Okay.
So let's go ahead and create that. Let me go to my header file, and let me just create a private variable for my wxWindow. And we'll just call this Paint Window. So wxWindow, Paint Window, without the S. And let's come over to here and just create our new window. So Paint Window equals new wxWindow, and the first one's going to be our ID, so we're going to need an ID for this, and we'll just call it paint_window. Oh, and don't remember, you should have stopped me here because the first one is supposed to be the parent, so
which should be this.
Should be this, exactly. And for
should stop you. I was just waiting for it to give you errors at compile time so I could say
yeah, it's very nice of you. The rest, the position, the size, we'll just leave as default because we want to fill the entire window. So let's just end it there.
But now let's go ahead and set up our enum for Paint Window.
Right. So let's go back to our header file here. Set up our enum ID list. And let's just come into here and say paint_window equals 400.
340.
340. Now, the main event that happens, let's just go ahead and run this. Let's just give it a second. And no errors, haha. As you can see now, it has this big window covering the entire area. When I move this window off screen, half of the window is blocked off, right? So when I move it back, it needs to repaint this side of the window.
That's correct.
So the event that's called, remember we're saying that events are happening all the time. One event that's called when the window comes back into view is the paint event.
Right.
And that event needs to be captured so that we can, when it's off screen and comes back, we redraw whatever we want on the screen. So let's exit this and capture that paint event. So come over to Paint Window. In this case, we'll use the connect, the dynamic event handling to actually connect to the paint event. So we'll say connect, and the first one's going to be which ID. In this case, it's going to be Paint Window. The second is the second ID, so that just needs to be -1. And the event we're going to capture is event paint. And then, of course, which function we want to call. So let's just call it onPaint.
Okay.
And of course, we need to cast this to the wx object event function. So object event function, and it's going to be mainFrame onPaint. Now the last two, let's set this to null, and the last one is going to be this. Basically, what this says is which onPaint function we're going to call, because remember, mainFrame is a class, right? So you can create different instances of a class. In this case, Paint Window needs to know which instances onPaint function do I really want to call.
Right.
Well, I want to call this is onPaint function.
Right.
So let's go ahead and go back to the mainFrame and create this onPaint event. So onPaint, it returns void, and just like before, but in this case, remember we used to always create wxCommand event as the argument. In this case, we're going to create a wxPaint event, and the reference to that. So something like that. And let's just copy this, come back over into our CPP, and declare the actual function. So mainFrame. So there. Now, you never really draw directly to a window. You don't just say paint window dot draw line, draw this. What you have to do it through is what's called a device context, and that's kind of the outlet into the drawing area. So you always have to have some sort of device context to draw to. So when you're in the onPaint event, you have to create what is called the wxPaintDC. Now, if you're drawing outside of this function, like if I create another function where I want to draw something, I would create what's called a wxClientDC. But when you're in an onPaint event, you have to create a wxPaintDC. And in the constructor for this DC, we'll just call the variable DC, you want to pass the window that you want to draw to. In this case, we just want it to be the paint window. So in here, what we can do is say dc.drawText. It has all sorts of draw functions. In fact, let's go over to wxWidgets, the help file, just so you can see a list of all the different events that we have, the functions that we have available to us. So if you look down here, check this out. We have draw bitmap, draw circle, draw polygon, draw text. Everything is available to us with this method here. So if we come back to here, we can say draw text, and let's just draw, I don't know, painting is cool. I know, very fancy. And then we just pass it an X and Y position where we want to print it. So maybe 60 across and 70 down. 60 and 70 are my magic numbers. Let's just compile this. And if we run this, you'll see it says painting is cool. That's very nice. And if we move it off the screen, when you start the application, an onPaint event is called so that it draws it initially. But since it is outside the viewing area now, when I come back, it calls onPaint and it repaints everything so that we see it. Now, this may not be always what you want to do. What if you wanted to create a paint program? Let's say like Photoshop, where you draw the mouse and it draws some sort of image. Well, that can't be done in the painting class because that's only called when it needs to be repainted. So we need to capture, say, the mouse event, the mouse movement, and then draw there. And that's where we would use the wxClientDC. So let's exit that out and be very, very careful. When you're inside onPaint, you need to create a wxPaintDC to draw to, and then actually do something. Otherwise, you could have it so that your application stops exiting. It will just start causing all sorts of weird errors. So if your application suddenly stops exiting for some reason, you press the X on the top right and it just doesn't exit, it's probably because your onPaint function is not handling the event properly. So with that out of the way, let's go ahead and connect another event, which would be the window, the mouse movement. So let's connect, again, it's going to be paint window. And in this case, it's going to be the mouse movement, so wxEVT motion, which is the mouse motion every time the mouse moves. And here we'll, again, cast the event function. And let's call this on motion. Makes sense. And again, we're going to pass it this so it knows which member function to call. Now, if we go back to the header file, let's actually create our onMotion event, or our message handling function. And in this case, we're going to pass a wxMouse event. Easy enough. And if we come back, let's just copy this prototype right here. Come over to here, and actually create it. Now, in this case, we're going to do some interesting stuff inside the onMotion. Now, there's another important thing to mention here. If I draw something in the onMotion, it will draw, but then when the paint comes along, it's going to erase all that. It's not going to redraw it. So we're going to kind of have to erase it every time. So let's come into here and say, let's say we want to draw a, I don't know, a circle.
Do a circle.
Okay. Again, we have to create our client DC, and this is going to be holding our drawing area, if you will. We'll just call this destination, and again, in the constructor, we'll pass it what window we want to draw to. And let's draw it in the center, so let's just say destination.draw circle, and let's pass it a position, wxPoint 50, 50, and let's just set the radius to 10. Now in this case, it's just a static position. In a minute, I'll use the actual mouse position, but I want to show you how this works. So as I'm moving the mouse, it keeps drawing this circle in the top left. It's stagnant. But when I move this off and back on, you'll notice it disappears because it's not drawing. But when I move my mouse in the area again, dink, it comes back to view. So that's something important to keep in mind. If you want this to stay here, so like you draw here, you move your mouse over, you want to save it, you'll have to use what is called a back buffer. And we'll be learning about that later in another VTM. In the next VTM where we'll be using it. So let's just exit this out. And let's get the actual mouse position. And that's where we can use this event handler that is passed to us. So we can say wxPoint, a position, and we'll just call this mouse position. And event, which is what is passed to this function, dot get position. and that just returns to us the position of the mouse. And right here, all we need to do is a mouse position. And this is something that's going to be changing constantly as the mouse moves. So let's compile this, and if we run it, you can see that now we leave a trail of little circles. Very cool indeed. But you might be wondering, why is it that the outline of the circle is black and the inside is white?
We're dealing with two different things here.
We're dealing with two separate objects here. There's what's considered a pen and what's considered a brush. The brush is what you see inside the circle. Yeah, the filled in area. And the pen is what's on the outline. So if you draw a rectangle, it's going to be the outline, etc. So if we want to change this, it's very easy. All we need to do is come in here and go to dest, which is our client DC, and let's say set pen. And if we want to set the color to, say, blue, what we could do is pass a wxColor object. Now, a pen pretty much only has one argument that you need to pass it, and that's the color of the pen. So in this case, excuse me, let me backtrack a little bit. A pen object is looking for a new pen, right? So it's not just a color typically. You would be actually looking for a pen object, but it converts it. Let me go over to here just so you guys can see how this is working, because I'm kind of jumbling myself up here. Ding, ding, ding. Go down to set pen. It's looking for a constant pen object. So what we can do is create a wxPen. But here's what I want to show. This is where I was kind of going with this. If I look for a wxPen object, you'll notice that it also looks for a constructor of a color object. So if we say wxPen constructor, you'll see that right here, the first argument that we need to pass it is a color. And so that's all we need to do is come over to our app here, and with a wxPen object, pass it a new color. And what kind of color do you want? This is an RGB value, so we
can do all whites this time around. 255.
Okay. Well, doesn't it default? No, it defaults to black. So 255, 255, 255.
That way, it'll just look like it's a solid
white thing.
Yeah, thing sounds good.
Yes. So as you can see, it's now a solid white object. And there are ways to kind of simplify this, if you will. In this case, it's a regular color. So if we just block this off, there are a few colors that are built in that we can use. So set pen, and then just get the address of a wx white pen. So there's like a black pen, a white pen, and that just kind of simplifies it. So, well, semicolons are a good thing. And basically simplifies it. If you're using basic colors, no need to type all of that out. So if we run this, it's the same as before. Now, if we want,
of course, I'm sorry. Go ahead.
No, go ahead.
I was just gonna say you can drive in the point about taking that off screen and then back on screen. You're gonna lose.
Yes, exactly. It's a really good way to show that off. So let's exit that out. And if we want to change the inside, all we need to do is do a set brush. So if we change this to .set brush, we can, as we did up here, create a new brush object and the color. So let's do that. Let's create a like a weirdish color. So wx brush, and we'll pass it a color object. Let's just throw in some numbers. It's some color. Give it a moment. As you can see, that's kind of a purplish looking color, and it works fine.
Yep. Now all we need to do is adjust our pen to match the same color, which we could do with the line that you've commented out.
Yep.
And it would look like we're now making strokes with that color.
Exactly. So that's pretty much all there is to actually creating objects. I mean, we could do a draw rectangle where you specify the width, height, and position, etc. There's all sorts of drawing functions. You can play around with it. But now what I want to talk about is actually drawing bitmaps, something that you could load from a file. Now, we created off-camera this very, very fancy image that just says 3D Buzz on it. Yes, very fancy. And it's called test.bmp. So I want to load this image and print this onto the screen. So if I come back into .NET here, let me just comment this out because we're going to be drawing bitmaps now, something completely different. And we're going to create a wx bitmap. Completely makes sense. We'll just call this my bitmap. And what we want to load is test.bitmap. Now, what you would typically do here is not use wxBitmap. wxBitmap is what we would hold. That you can't draw a wx image. We have a wx image which allows us to load images from disk, but you can't draw a wx image to a DC, a device context. You have to use a bitmap. So we're going to take in whatever image we create. Let's say my image, which we haven't created yet. Does that make sense?
Mm-hmm.
So right here we'll create a wx image, and it'll call this my image. And in the constructor, if we scroll down a little bit, string name. this will be the name of the image that we want to load. So all I need to do is say test.bmp. Now this is, of course, when I don't specify a path, it's going to be a relative path. So wherever the executable is, that's where it's going to look for the image. So in this case, if I do that, wxImage will now load that bitmap from disk and then store it into my image. Now, what's really cool about this is wxImage can load more than just a bitmap. It can load JPEGs, it can load TIFFs, and remember when we compiled it in the first lesson, we could set that.
Right.
So if you want to disable certain ones, you can. If you want to decrease disk size, etc. And so right here, that creates it. Now to draw it, it's very simple. All we need to do is say destination.draw bitmap, and then we need to specify what bitmap we want to draw. This is going to be my bitmap. Where do we want to draw it? We'll just draw it at the mouse position. And the last argument here says whether or not we want to use a mask color. And we'll set that in a second so that you can see the difference. So if I compile this, you'll notice one small problem. My image uses undefined class wxImage. To fix this, we just go to the header file, and we need to include a new header file called image.h, which basically holds all the things dealing with images. So if we rebuild this, ding, 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 everything works good. If we just run this, you'll notice it's now printing out that bitmap, no problem at all. What if we wanted to make it so that all the white is basically masked out? This is very easy to do. If we just exit this out, in the image class, the wxImage class, we can say myImage.setMaskColor right here. And we can pass it a color RG and B that says what color we want to mask. In this case, it would be white. So we just say 255, 255, 255. And, of course, I almost forgot here, I'm compiling. If I do not set this to true, as you can see, it's still printing out the white. I don't want that. I just need to set this to true, and then it'll actually utilize the mask that I set up above. And as you can see now, it's completely working. Very, very nice. Now, bitmaps, using disk to manage your actual bitmaps is a good way. Often you'll want to do that, but sometimes people will want to store whatever bitmaps they use inside of resource files. Resource files are cool because it's compiled into your actual application, so that you don't have external files, people don't get confused, etc. So it's a good way to manage your bitmaps if you don't have a lot, or it depends on what you're doing. So what we can do is come over to the resource view here, right click and go to add resource, and in this case we want to add a bitmap. So let's just press new to this guy. So now that we've added this bitmap resource into our resource file, we can start editing this bitmap kind of with the basic functionality of a paint type program, like Photoshop.
It's like .NET suddenly turned into a mini Photoshop.
Yes, it's very cool. If you can see up here, I hope you can see up here, we have all sorts of different tools that we can use, like the pen tool right now, so we can draw little cool shapes. We have a brush tool, we have an airbrush tool. Pretty much like any paint program that you're used to, we can change the colors over here with the color palette and modify that. So just some basic tools that we have. We can even draw
text, shapes, etc.
Yeah, we can even draw rectangles if we wanted to. So just basic stuff that we can do. Now, if you notice over here in the resource view, the current name is idb_bitmap1. If we wanted to change this, we can go over to View and go to Properties window, or just press F4. And with this one selected, we can change the colors if we wanted to. Right now it's just 16 colors, and right now that's kind of limited.
That's right.
We can change this over to 256 color or true color if we so desired. And if we click this, you'll notice it automatically adds all these different colors. So we just suddenly have a whole new array of colors we can choose from. Very special. The ID, let's go ahead and change this to something so that we can go ahead and use it. So we'll change this to, in quotation marks, item.
Okay. And you'll notice it changed in the resource view.
Let's go ahead and save all of these files here. Exit this out and exit the properties window, and let's make use of this item here. So let's kind of just comment out all these lines here, and then create a new WX bitmap, and we'll call this my resource. And we'll equate this using the cool macro, if you will, the bitmap, wx bitmap, which allows us to load a resource. And we'll just call this item, because we named it, in quotation marks, item. To load the resource, we simply pass item to this macro, and it will convert it into a bitmap and store it into my resource.
Right.
And now, a matter of printing it is simply copying my resource
and replacing my bitmap.
Exactly. So if we want to compile this, and we just give it a second, and you notice another step, if we just go up here for a second, we have compiling resources. this means that the resource file is now integrated into the final executable, which is very cool.
Convenient when you have, let's say, quite a few small icons and all that.
Yeah.
That it would be more convenient to have them packaged in the executable as opposed to extra
have separate files.
That's right.
And if we look over at our Solution Explorer, you'll notice that under the Resource Files folder, we now have Bitmap 1, which is the bitmap we just created. Very, very cool stuff.
Right.
So if we run this, check it out. Our very, very fancy modern art is now being printed to the screen. So I guess with that pretty much covers everything we wanted to cover in this lesson. I mean, we've covered how to create bitmaps, how to draw simple shapes, using the device context, and all sorts of very cool stuff.
That's right, and we're going to be using resource files quite a bit when we start getting into the next VTM and we port our game over into the Windows world.
Exactly.
Okay, with that, that's going to wrap up this lesson. Thanks a lot.